Welcome to 10 minutes CS. 2583 kth largest sum in a binary tree. You are given the root of a binary tree and a positive integer k, and we need to find the kth largest level sum of the tree. What is a level sum? So let's say this is level 0, 1, 2, 3, and these 0, 1, 2, 3 defines the distance from the root. So the distance from root for 5, as in it itself is a root, so it will be 0. For 8th and 9th root, we just have one edge, so that will be 1. Similarly 2 and 3. So the sum of these values will be the level sum of this binary tree. So this will be 5, this will be 17, 13 and 10. Now we need to find the kth largest level sum. So k in this question is 2. So in this example is 2. So the second largest among all this is, first largest is this, second largest is 13. So we should return 13. Now there are two things in this question. The first thing is we have to find level sum, which is same as BFS. We are just doing BFS over this tree, and each time we will just add all the values at a particular sum and we should store them somewhere. Now how should we store them? Here we have to find the kth largest. So for all such questions where we have to find kth largest or smallest, we can use a priority queue, because what a priority queue does is it gives the smallest of all the values or largest of all the values depending on what we have defined. If we have defined it as a min heap, which is by default in Java, so it will give the smallest of all the values present in the priority queue at that moment. So we can store it in a priority queue. Now how will we proceed with this? We will start with the root, we will do a BFS over it, and for each time when we are doing, we will sum the values for each level, and then we will keep on adding it to our priority queue. Now while doing a push, we should see, first of all we should define the priority queue of size k. So we should see if the size of our priority queue is less than k, that means we still have room for adding more numbers, so we will simply push it in our priority queue. Else if our priority queue is already full, in that case we need to pop some element out of it. So as we have defined our priority queue as min heap, which is by default, so we need to pop the element. Now each time when we will pop it, it will give us the smallest among the values. So let's think of this same example. We have defined a priority queue and it is of size 2. So first of all we added 5 as its size was less than 2. Now we got 17, so we added 17 here. Now we have 13, but the size of the priority queue is already full, so we need to take out the minimum of these. So we will take out 5 in this case. So after removing 5, we can add 13 here. Now next we got 10. Now we don't have room for 10, so this time if we will pop, we will get the smallest of 13 and 17. So 13 will be removed and in its place 10 will be added, but that is not what's needed. So what we have to keep in our priority queue? All the elements which are either greater than or equal to the kth largest of our level sum. So here we should add a check. If our pq.peak is lesser than our level sum, in that case only we will poll and we will add the value, else we can just go forward. So in this case the 10 is not the right number that we need, so we won't do anything and we will just simply proceed. So let's write the code for this algorithm. We are given a function kth largest level sum and root and k as our arguments. Our return type is long, So we will initialize our priority queue with long data type. Now we will do the BFS. For that we need a queue. We will add root to our queue. So let's say this is our queue and this is our priority queue, and for this question our k was 2, so our priority queue will be size 2 here. So first we will add our root to it, then we will check the size for it, and the size here is 1, and we will run the for loop for all the nodes which are present in our queue, and we will poll them. Now 5 is our current, we will add it to our level sum. So our level sum was initially 0, so we added it to it, and then we see if our current dot left is not null, then we will add it to the queue. Similarly we will do for the right child. Now our priority queue size is less than k, so we will add our level sum value here. Now we will move on to our next iteration. Now we have size as 2, we will run it for 8 and 9. So first we will do it for 8, we add 8 to our level sum, and we added its child to our queue, and after that we will do it for 9 also. We add it to the level sum, so it will become 17 here, and we add its child to our priority queue. And finally our priority queue size is less than k, so we will add it here. Now we will go for our next iteration. Now our size is 4, and it will check for all of them, so it will keep on adding it to level, and it will check if its left and right are not null, so it will add it here. That will be the next level, and then it will go for 1, it will add 1 here in the level sum. No left and right child, so it won't be added to priority queue. And then it will go for 3, so it will add 3 here, then for 7, so finally it will be 13. Now it will see that if the peak element is lesser than our sum, level sum, so it will take out this, and instead of this it will add 13. Let's erase these. So our 13 will be here. Now our size is queue size is 2, and level sum will be 0. So we will pop the element, we will add it to our level sum, and its left and right child both are null. And similarly we will do for the next child 6, we will add it to our level sum, and its left and right child are null. So now it is equal to 10. Now we see that our priority queue peak element is greater than 10. So we are talking about this condition, it is greater than 10, so this condition won't be run, and we will just simply proceed to our next. So now our priority queue is empty, so we will come out of this while loop. Now we will see if our priority queue size is less than k. In that case we can just return -1. So this will be a case when, let's say, our k was given as we have 0, 1, 2, 3 levels here, so 4 levels here. So if it was given as to find the 5th largest level sum, so we don't have a 5th level in here, so in that case it should return -1. Else we can just return pq.peak, that will be 13, so 13 will be returned. The time complexity of this algorithm will be, we are running our while loop for all of the levels, so this will be running for each level, and inside we are running for each nodes in that level. So overall it is running for all the nodes, that is n. So let's say there are n nodes in the binary tree, and among all these we are doing the operation of peak. So for this we are using log k because the size of our priority queue is k. So our overall complexity will be n log k. And our space complexity is we are using here additional priority queue and queue. Our priority queue size is k and our queue size can go up to max of the number of nodes in the nth level. So let's say so that will be max of k comma n. We can take it as n. Thank you for watching.